Welcome to BakoMaths, and to this lesson we'll be looking at radical equations. Kindly subscribe and hit on the notification bell for more updates. Now let's get started. So when you talk of radical equations, we are talking about equations involving square roots, cubic roots, and other radicals. And this is a clear example. So it says you should solve the equation square root of x squared minus 7 is equal to 3. So now we have our solution, and the question was giving us square root of x squared minus 7, which is equal to 3. So in this instance, we can see that the radical has been grouped, and then the rational numbers have also been grouped. So we can see the radical x squared minus 7, that is square root of x squared minus 7 at the left hand side, and then the rational number 3 at the right hand side. If this is done, we proceed by squaring both sides in order to do away with the radical sign or the square root here. So here we write our square root of x squared minus 7, and then we square both sides. So we square both sides of the equation. So now we have this, we can see that the 2 will cancel the square roots, and then we will be left with x squared minus 7, which is equal to 3 squared gives us 9. So once we have this, we have to group like terms and find the value of x. In this case, we maintain x squared, which is equal to 9, and transpose the minus 7 to the right hand side, which gives us plus 7. Now we have x squared here to be equal to 9 plus 7 gives us 16. So at this point, we can solve for the value of x, or we can solve for x by squaring both sides again to take away the square. So we have the square root of x squared, and then it's equal to the square root of 16. At this point, we can see that the 2 cancel the square roots, and then we are left with x, which is equal to the square root of 16 is giving us plus or minus 4, which implies x is equal to 4 or x is equal to negative 4. Now this becomes the solution, but in radical equations we have to check for extraneous solution. When we talk of extraneous solution, we are talking about solutions that are derived from the question but are not valid answers to the question. So in doing so, we substitute the value of x back into the question to see if it clearly satisfies the question. So let's write here, checking for extraneous solutions. Checking for extraneous solution. So we say for extraneous solution, the value of x that do not satisfy the question itself. So wherever we see x in the question, we substitute the value of 4. So in the question, we have square root of x, and then x was found to be 4. So we write the first value was 4. We write 4 here, and then we square it, and then we bring our minus 7. We want to see if when we simplify the left hand side, we get 3. So we can see that we have here 4 squared gives us 16, and then we have minus 7. We want to see if indeed we get 3 here. So we keep on simplifying, and we can see that the square root of 16 minus 7 gives us an answer of 9. We want to see if square root of 9 is equal to 3, and indeed square root of 9 gives us 3. So we know that square root of 9 gives us 3, which is equal to 3 here. So indeed we can see that x is equal to 4 is not an extraneous solution, but a real or a valid answer to the question. Let's find out for x is equal to minus 4 in this case. So we continue, and we can see that we write our question, and wherever we see x, we substitute minus 4. So here that gives us, it says x squared, so that is minus 4 all squared minus 7. We want to find out if indeed we get 3 here. So square root of minus 4, that is minus 4 all squared, gives us 16, and then we have minus 7, which is equal to 3. So indeed 16 minus 7 gives us 9, that is square root of 9. We want to find out if you get 3 here, and square root of 9 is 3. So that is true. So therefore we can say that there are no extraneous solution here, and indeed the answers x is equal to 4 or x is equal to 4 are valid solutions to the question. So sometimes not all the values of x we derive from the question are correct. Sometimes you have to check for extraneous solution and then exclude them as part of our answers to the question. So that is example 1. So you proceed to example 2. So example 2 says that we should find the value of x in the equation square root of x minus 3 all exponent 3 minus 64 is equal to 0. Now these are the basis of radical equations. As we proceed, we'll be having a bit challenging questions. So here we have the square root of x minus 3 all exponent 3 minus 64 is equal to 0. So just like we said earlier on, for radical equations, to ease the work, we group the like sets or the radicals at one side and group the rational numbers at also one side. So in this case, it means we have to transpose the minus 64 to the right hand side so that we can have the radical x minus 3 all exponent 3 here, and then to be equal to 64. Now because there is a square root sign here, we have to eliminate it by squaring both sides of the equation. So here we have the square root of x minus 3 all exponent 3 and then squared. So we square it, and then we also have 64 all squared. Now in this instance, we can see that the square will cancel the square root and we are left with x minus 3 all exponent 3, which is equal to 64 squared, and 64 squared is known to be 4096. Now that we have this one, it means that since there is also an exponent of 3 here, we'd have to take the cubic root of both sides so that we can eliminate the exponent of 3. In this instance, we have the cubic root of, so this 3 indicates it's a cubic root of x minus 3 all exponent 3, which is equal to the cubic root of 4096. In this instance, this cube will cancel the cubic root and we will be left with x minus 3, which is equal to, so the cubic root of this gives us 16. In this case, we solve for x by transposing the minus 3 to the right hand side, and finally we have our x value to be equal to 19. So there is one value here. The fact that we have one value doesn't mean that we cannot get a extraneous answer. We still have to check if the 19 here is an extraneous solution. So we substitute the 19 to the question wherever we see x, and then we simplify to see indeed if you are going to get 0. So let's write here checking for extraneous solution. Checking for extraneous solution. So in checking for extraneous solution, wherever we see x in the question, we substitute 19. So here we are going to have the square root of, so x, that is 19 minus 3 all exponent of 3, which is minus 64. We want to find out that when we simplify this, we are going to get 0. So we continue, and here we can see that 19 minus 3 gives an answer of 16. So you have 16 exponent 3 here minus 64. We want to see if indeed we get 0. So we continue simplifying, and the cubic root of, the cube of 16 gives us 4096, and then bring our square roots and then minus 64 attached, which is equal to 0. Now square root of 4096 is nothing but 64, and they have minus 64, and clearly you can see that 64 minus 64 gives us 0, which is definitely equal to 0. So therefore we can say that s is equal to 19 is indeed a solution to the question and not an extraneous solution. If 19 is an extraneous solution, then we can say that there is no solution to this question. But clearly we can see that 19 is a solution, so therefore x is equal to 19 indeed. Now to the last example of this video, we solve it. Now this marks the last example for this video, and it says we should solve the equation x plus square root of x plus 1, which is equal to 5. And at this point, if you have not subscribed to BakoMaths, kindly spend a moment and subscribe. Share the video to your friends and like as well. So here we have our solution, and we have x plus square root of x plus 1, which is equal to 5. What we can do here is to group the radicals at one side and the rational numbers or the non-radical numbers at one side. So in this case, we are going to have the square root of x plus 1 here, and then we transpose the x to where 5x, so that is 5 minus x. What we are going to do again is to square both sides, that is x plus 1 squared, and then we are going to have 5 minus x squared. So the square will cancel the square root, giving us x plus 1, which is equal to, so you have to expand this. Now you can expand this by using the short procedure, which says that if you have anything of this form and you want to expand, you can do it by saying we square the first number. So the first number, that is 5 squared, gives us 25, and then we multiply these two, the numbers in the bracket. So we multiply them, it gives us minus 5x. That answer minus 5x, we multiply by 2, that gives us minus 10x. So minus 10x. Now once we are done, we square that of minus x. So minus s squared gives us plus s squared. So it means that wherever we see 5 minus s all squared, we write this expansion rather than going through the normal procedure, of which it will drain us in terms of time. So here we have, so that gives us 25 minus 10x plus x squared. So once we have this, now we group like terms and find the value of x. So here we maintain x squared, and then we maintain minus 10x. We transpose x to this one, that gives us minus x, and then we also maintain 25 and transpose 1, becomes minus 1, of which you have 0 here. Now at this point we continue by simplifying this way, so that gives us x squared. Now minus 10x minus s gives us minus 11x. 25 minus 1 gives us plus of 24, which is equal to 0. So this is a quadratic equation, and we can easily use a calculator to find the factors. We can simplify it. So the simplified factors for this quadratic equation gives us x minus 3, and then we have x minus 8, which is equal to 0. So here we can see that when x minus 3 is equal to 0, x is equal to 3. In the same way, when x minus 8 is equal to 0, we have x to be equal to 8. So these are the values of x, but we have to check for extraneous solutions and identify the one that really satisfies the equation. So we write checking for extraneous solutions. So checking for extraneous solutions, we have this. Now remember, for extraneous solution, we substitute the value of x into the equation itself and see if they really satisfy the equation. So we have, for x is equal to 3, we substitute into the equation that said x, so wherever we see x, we substitute 3 there. So wherever we see x, we substitute 3 there. So that said 3. All right, so that's a 3 plus square root of 3 plus 1 should give us 5. So let's see if indeed we get 5. So 3 plus square root of 3 plus 1, that is, we have square root of 4. Let's see if indeed we get 5. So 3 plus square root of 4 is known to be 2. And then we can say 3 plus 2 gives us 5. So indeed we have 5 here. So here we can see that s is equal to 3 is a solution. Let's check for the other one. That is when we see for s is equal to 8. Then wherever we see x, we write 8 there. So that gives us 8 plus square root of 8 plus 1. Let's see if indeed we get 5. So here we have 8 plus 1 gives us 9, which is equal to 5. Now at this point, you can clearly see that there is no way we can add 8. Okay, we can, but yet we can simplify. So that gives us 8 plus square root of 9 is 3. So let's see if indeed we get 5. But when we sum 8 and 3, we get 11, which is equal to 5. But there is no way we can sum 11. There's no way 11 is equal to 5. So we can see that the value for s is equal to 8 is not a solution to this question. So we have been able to identify one extraneous solution here. So s is equal to 8. It's not 5, because whenever we substitute 8 here into the question, we are getting 11, which is not equal to 5. So we conclude by saying, therefore, x is equal to 3 is a solution since it satisfies the original equation, whereas s is equal to 8 is not. So after writing this, then we conclude as such. So the only answer to this question is s equal to 3, but s is equal to 8 is not a solution to the question. So we end today's video here, but kindly check for the video next to this one for more challenging questions on radical equations, because these are the bases to radical equations. For challenging questions and standardized questions, kindly check for the video next to this and work it out. So this is BakoMaths. Thanks for watching. Kindly like, comment, subscribe and share. Remember that this is BakoMaths. We are thinking beyond infinity.